welcome back. So we solved the second part of question 1 in the cut. So if u equals log of x cubed plus y cubed plus z cubed minus 3xyz, show that the square of partial x plus partial y plus partial z of u is negative 9 over x plus y plus z squared. So one thing that you have to know is that in this context, this function log given in this problem should be interpreted as the natural logarithm. So let's get the partial derivatives of u. So solution, partial u, partial x is given by, so you write the whole function given in these brackets here, and then partially differentiate the function with respect to x. So we'll have x cubed plus y cubed plus z cubed minus 3xyz, and then 3x squared minus 3yz is the derivative of that function partially with respect to x. So call this one equation 1. And then the second will be given by partial u, partial y, which is you write the function in the bracket in the denominator, and then differentiate it partially with respect to y, and you get 3y squared minus 3xz. You call this one equation 2. And lastly, differentiate that function with respect to z. So partial u, partial z, what is in bracket is written in the denominator. Then differentiate partially with respect to z, so we get 3z squared minus 3xy. And the assumption taken here is that you have known how to deal with logarithmic functions in calculus. So adding equation 1, 2, and 3, we get partial u, partial x plus partial u, partial y plus partial u, partial z is given by, now we'll have denominator is common, x squared, x cubed plus y cubed plus z cubed minus 3xyz. And then the first was 3x squared minus 3yz. Next was 3y squared minus 3xz. Next was 3z squared minus 3xy. And then you can write this sum as, so bring these squared terms together. So you can say 3 into x squared plus y squared plus z squared, and then minus, because I've factored out x, I've factored out 3. So I say xy minus yz minus zx. I divide by x cubed plus y cubed plus z cubed minus 3xyz. So this is the same as partial u, partial x plus partial u, partial y plus partial u, partial z. Now, you should see that this denominator can be written in the form, so you write this one 3 into x squared plus y squared plus z squared minus xy minus yz minus zx. The denominator can be written as x plus y plus z, then multiplied by x squared plus y squared plus z squared minus xy minus yz minus zx. So the trick in this question was to show that this bracket is a factor of the denominator. Now, once we have done that, those two brackets cancels out. So this bracket and this bracket cancels out. So then we remain with i.e. partial u partial x plus partial u partial y plus partial u partial z will be given by 3 over x plus y plus z. So that was the first thing to note. And you see, this sum can be written as partial x plus partial y plus partial z, and then this are subjected to u is equals to 3 over x plus y plus z. So in the question, they wanted us to show that when we square, then we should get -9 over the square of the denominator. So this implies that partial x plus partial y plus partial z squared is the same as partial x plus partial y plus partial z then u function is 3x plus y plus z. So that's what it means. So this is the same thing as saying partial x of the function 3x plus y plus z plus partial y of 3x plus y plus z plus partial z of 3 over x plus y plus z. So this is partial z. Please just note that now this sum of the partial derivatives, understand it the way we write just sum of one partial z. So you see when we write partial squared partial x squared, we mean we mean partial x of the first derivative of the function u. So that's really, but now this is in terms of sum. That's why this one implies this. So this will give us, you can write this one as partial x of 3 into x plus y plus z raised to -1 plus partial y 3 into x plus y plus z raised to -1 plus partial y into x plus y plus z. So this is z. And then this for -1. So this one will give you minus 3x plus y plus z raised to -2 minus 3 into x plus y plus z raised to -2 plus but minus, drop this one, so we'll have x is a 3 y plus z raised to -2. So remember what we are using here is chain rule. So this will be, so all this -3 minus 3 is -6, and then -6, or we can just write this one -3 properly. So this -3. So I can factor out x plus, actually there's no need of factoring. So these actually, all of them are like terms. So -3 minus 3 minus 3 is -9. So I write this one -9 divided by x plus y plus z, and then squared. So this is how that problem was to be proved. So the trick was to show that this numerator here, bracket, is a factor of this given denominator. And then once we have done that one, then define the sum in terms of the derivatives, and then work out the partial derivative of second partial derivative of this u function. Thank you.